Hi guys, hope you all are doing well. Today we are going to do deviations from mean. Now, before we start with that, I want to talk a little bit about statistics. GMAT with time is moving towards content that is a lot more relevant to real world. So this is the reason why geometry was done away with because it is relevant for engineers, relevant for architects, but when we talk about MBAs, when we talk about people in the management, geometry isn't really relevant for them. Of course, number properties is extremely important. Arithmetic is extremely important. And then so are statistics and probability. Algebra is anyway the basics, the core of mathematics. So it's good to know that as well. And they have done away with AWA as well because, of course, evaluate the argument is a part of your critical reasoning question. So it doesn't really make sense to have another one. So that works. And sentence correction also, well, I have a theory about that and we'll talk about that some other day. So today we are going to talk about statistics and that central tendency thing that is extremely important. Your arithmetic mean in statistics is extremely important. So you should understand it really, really well. Right. So today I have a few questions in which we are going to discuss deviations from mean. Now, these are all 700 plus level questions. These are, the ones that people found a little difficult to solve. So I'm sure we're going to have fun with them. So in the 50 to 80 kgs weight category of boxes, so the first thing that tells me is that there is a lower and a upper limit. So there is a 50 kg lower limit and an 80 kg upper limit to the actual values. The average weight of all 10 boxes was 60 kgs. Now, the moment I say average was 60, what is the thing that has to come to my mind? It has to be 60, 60, 60, so on 60, right? This is what now I'm imagining. Okay. If the 5 heaviest boxes are not considered, now let's say here are your 5 lightest ones and here are your 5 heaviest ones. Yeah, their actual values would be something different. Doesn't matter. We've ranked them as per their weights. That's fine. Just that this is the entire list and these are your 5 lightest and these are your 5 heaviest. Whatever their actual values are, we'll ignore it for the time being. When we put these aside, then what happens to the average over here? It falls by 2. So now the average over here has become 58, 58, 58, 58, and 58. So now each one has 58. What does it mean that the average falls by 2? That means when I took these people out, when I took them away, they had given 2 extra to each member of this group. So when they left, then their 2 also went away with them. So that means there was this 10 extra that had been given to this group, to the lighter group, which now went away with the heavier group. So now these people had that 10 extra with them, right? Now, if they have the 10 extra, what does that mean? It means that it obviously, since we're talking about average, it has to be equally distributed among everyone, right? So then the average over here would have become 62, 62, 62, 62. Makes sense? The average over here would have then increased by 2 because this 10 extra would have been distributed in this group. So everyone would have gotten a 2. All right. Now, given that each of the 5 heaviest boxes had a distinct integral value of weight in the category, so it means that their weights were, each one of these was a distinct integral value. So they can't be all 62. They would have been different. The maximum possible weight of a boxer is, now maximum possible, since we have arranged them in a row, in a ranking, this guy would be the heaviest. So we are saying that what is the maximum possible weight of this guy? Look, again, 62 is the average, right? So we've written them all as 62. They will each have a different weight. And we've been given that it is different for each 5 of these people and it is an integer value. So I want to maximize this value. So if I want to maximize this value, it means that I should try to minimize the other values. I should try to make them as less as possible so that this can be as high as possible, right? Because after all, overall sum stays the same, isn't it? All right. Now, if I want to minimize the weight of these four, what is the minimum weight that they can take? What about this fellow, this sixth guy in the ranking? What weight can he take? Look, his minimum weight can be 59. Now, why is it that his minimum weight can be 59? Think about it. Let's say all of these are 58, right? Now, since his weight has to be more than this fellow's weight, and since it has to be distinct from all the other weights, this guy's weight has to be distinct from all the others, so it can be 59, right? The smallest value that it can take. Now, if you say that, why is it that each one of these is 58? It is certainly possible, let's say, that this guy is at 57, right? Then you have 58, 58, 58, and this guy is at 59, because that is how averages work. In case I have someone who's one less than the average, another person will make up for it. We say that deficit is equal to excess, right? That is the whole concept of average. Now, what happens when this guy becomes 59, the fifth guy, he becomes 59? What happens then? Then this guy, the sixth guy, needs to be a 16, isn't it? In case I make anyone here less than 58, then here I'll have to make them greater than 58, which means that the sixth guy, since of course his weight has to be more than the fifth guy because it's a ranking, then his weight will increase and it will need to be 16. But if we want to maximize this guy, then we have to minimize this fellow, right? And this fellow, and this fellow, right? And this fellow. So then 59 is the minimum that this fellow can take, the sixth guy can take. And since the weights of everyone is a distinct number and they're integers, so that means that the weights will be 59, 60, 61, 62. These are the lowest possible values of these four weights, right? Now, what will be the weight of this guy? Again, we know that the average over here is 62, right? Now, the deficit here is of -1. Here, the deficit is -2. And here, the 59 is a deficit of -3. So then this guy will have an X. The deficit, total deficit is -3, -2, -1, which is a -6. So then this guy will have an excess of 6, and that is why his weight will be 68. And 68 will be the maximum value of weight that he can have. So our answer is going to be 68 kgs. Yeah. Tough one. But do you understand it now? Take a look at how the numerators and the denominators are increasing. Of course, there is a logic to it, right? Look at the pattern. So 3 by 7, then you have 5 by 9. So the numerator increased by 2 and so did the denominator. Then 7 by 11, numerator increased by 2, so did the denominator, and so on, right? So of course, there is a pattern to it. Now, in our number properties video, we've discussed this in detail, and it's a really important property. It will come in handy in a lot of other topics as well. And look, this is the hallmark of a good GMAT question. It will not test you on one concept. It will test you on multiple concepts together. So that is why you have to be really good at all of them. Yeah. And in identifying all of them as well. So whenever I see a fraction where the numerator and denominator, they're increasing by the same term, same positive number, then I know that I have to use that property. Now, what is that property? It is called tending towards 1, right? We'll call it tending towards 1. What that means is that, for example, I have 1 over here, yeah? Now, if I have a fraction which is less than 1, let's say I have half. Now, if I increase the numerator as well as denominator by the same number, let's say I add 1 to both of them, what do I get? I get 2 by 3. Now, half is here. My 2 by 3 is going to be somewhere over here. Makes sense, right? Because look, I'm thinking of a number line, right? So my 0 is going to be somewhere over here. This is my half. My 2 by 3, because it's 0.66, so of course it has to be greater than half. Next, if I increase 2 by 3, both numerator and denominator by 1, what do I get? I get 3 by 4. So my 3 by 4 is going to be somewhere over here. Of course, this is 0.75, right? So now what is happening? Look at that. I say now I have my 4 by 5. That is my 0.8. So of course, the numbers are increasing. When I add 1 to both numerator and denominator, the number is increasing slowly. That is, every next step is a little slower. Why? Because it's tending towards 1. Note that my numerator will always be 1 less than my denominator, so my fraction will never become 1, right? It's just moving towards 1. It's just tending towards 1. So, I can keep increasing on and on. I'll reach, let's say, 99 by 100. I'll reach 999 by 1000, whatever. Doesn't matter, but I'll never reach 1, which means that the distance between them will keep on becoming smaller and smaller. They'll keep becoming, they keep pressing together, but they'll still never reach 1, right? This is our concept of this is our, that number property that we use over here. Now, let me just remind you also what happens in case I have a number, let's say, which is greater than 1. Let me say this is 3 by 2. Now, I increase this by 1, both numerator and denominator. What happens? I get 4 by 3, right? This is my 1.5. This is my 1.33. What is happening here? Again, it is again going towards 1. Look, I'll get my 5 by 4 over here, right? 1.25. Again, it is going towards 1. Do you see? Now, the next number will be, let's say, here. The next number will be, let's say, here. They'll keep becoming closer and closer. They'll keep running towards 1, but they'll never reach 1 because the numerator is always going to be 1 more than the denominator. So it will always be greater than 1. So then remember that when and the same thing happens, it doesn't matter which number you add. I mean, it's okay, you added 1 over here, you could also add 2 to both of them. Yeah, you could say this is 3 by 4. Of course, 3 by 4 will also, from 1 by 2, when you add 2 to both numerator and denominator, you get 3 by 4. It is going to tend towards 1. So as long as you're adding the same number to both numerator and denominator, I'm talking about a positive number, it will tend towards 1. If it's over here, we're just talking about the positive fractions, yeah? If it is over here, then it will go towards 1 like this. And if it is over here, wherever, it will go towards 1 like this, yeah? And this is a very important property and you must keep it in mind. So now we'll use this property to find our answer over here. So now the numbers are 3 by 7, 5 by 9, 7 by 11. So then, to start with, this is less than 1, right? 3 by 7. So when I add 2 to both numerator and denominator, I know that my number will go towards 1, will tend towards 1. So I'm adding 2 at every step to both numerator and denominator. So then, of course, if my 0 is here, let's say my 1 is here, and I have my 3 by 7 over here somewhere, then let's say my 5 by 9 will be here. Of course, my 7 by 11. Do note that the distance between them is going to keep decreasing. Why? Because I have very little left over here. I have like infinite numbers, isn't it? So I have to put them all in that little bit of distance. So I keep putting them closer and closer and closer together. Just imagine it, visualize it. So it will be so much easier for you during the test. Yeah, visualize this thing. Now, this one, again, I'm trying to, I brought it a little closer. Then the next one, I brought a little closer, so on and so forth. Okay. So now when I have placed, let's say 3 by 7 and 5 by 9 and 7 by 11 and 9 by 13 and let's say 11 by 15 on the number line, I know the median. Where is the median? It is the middle value. Median is just simply the middle value. So it will be 7 by 11. But what about the mean? Where will mean be? Look, mean will not be at 7 by 11, right? Why? Because look at this. The excess is only this much. Whereas the deficit is a whole lot more from 7 by 11. So the mean is not going to be at 7 by 11, right? The deficit has to equal the excess for it to be mean, which means mean will be pushed somewhere over here. Here will be the mean and here will be our median. So mean over here is going to be less than the median. Look, it is to the left of the median on the number line, right? So my mean here is going to be less than my median over here. Okay. So then here mean is not greater than median for sure. Yeah. Okay. Now, will you try doing the same thing for the second one? If you've understood it, I'll give you 15 seconds. Just think about this. Let me know if if you can figure out whether mean will be greater than the median or not. Yeah, yeah. So it's decreasing. Look, all right. So you know, so if people are a little frustrated that here the numerator and denominator both are decreasing by 3, right? But then, look, of course, when you reduce both of them by this positive number, then it goes away from 1, and that's logic. But then instead of that, if you want to just think of one thing and not get confused, you can think of starting from 9 by 5, isn't it? Let's plot 9 by 5 first. Why do we have to plot 21 by 17 first? We are comfortable with increasing numerator and denominator by the same number, so let's start by 9 by, it doesn't matter, isn't it? So let's say if I say 1 is over here, my 9 by 5 is greater than 1 for sure. So it will be, let's say, somewhere over here. What happens when I increase both numerator and denominator by 3? Of course, then the number will tend towards 1. So that means it will go somewhere over here. And I'll have my 12 by 8 over here. Have I already got my answer now? Look, if 12 by 8 is here, then my 15 by 11 is going to be here, then my 18 by 14 will be over here, and my 21 by 17 will be somewhere over here, right? Since it's tending towards 1, the distance between them will keep reducing, and I have to do absolutely no calculations for this, yeah? Most people end up doing calculations and subtracting consecutive terms over here, but you don't have to. When you understand the concept, you have to do absolutely zero calculations, right? So now again, my 15 by 11 is my median. We know that, right? But it will not be the mean. Why? Because here my deficit is so much lesser as compared to my excess. So my mean will move somewhere over here. So here will be my mean and here will be my median. So of course your mean will be greater than median, right? Here mean will be, and here, okay, again, now look at this. Look at number 3. You have 7 by 11, 9 by 11, 11 by 11. The distance between all of them is the same. There is a gap of 2 by 11 in all of them, right? It is an arithmetic progression, right? So then your median and your mean is going to be at the same point, 11 by 11. So again, your mean is not greater than the median. And if I look at this one, 10 by 7, 12 by 19, I'm increasing numerator as well as denominator by 2. This is a number greater than 1. So again, it is the same case as number 2, right? Both the cases are exactly the same. Just that here I'm increasing both by 2. Here I was increasing both by 3. So here also your mean will be greater than median. And that is what your answer is. So for 1 and for 4, your mean will be greater than median. So for 2 of, yeah. Let me know if you're comfortable with this. Let me know if you understood this. It's guys, it's an important concept. Do remember that it will be useful in a lot of other. Look, this is not a number properties question, right? I mean, so whatever. It is a more of a mean median. So you think statistics, but this concept will be used at a lot of places. The pattern recognition is a trademark of GMAT. They love to use that. So it's important to know this property very well. It's very useful. Yeah, and number line, of course. We love the number line. So imagine things on the number line. It just makes it so much easier. You end up spending so little time. Look, when someone says that, time was less in quant, my point is that it shouldn't be. I mean, you should have enough time to even spend 5-10 minutes on a question if you wish to, because normally your questions shouldn't take more than a minute. I mean, there are methods available to solve them such that they wouldn't take more than a minute. Those visual methods, normally then. And GMAT question, we don't have too many calculations.